In this video, I'm going to solve two questions from the chapter Exponents and Power, class 8. The first question says that we have to write this in the scientific notation. So first we'll write the number. It is 7, 4, 9, followed by 1, 2, 3, 4 zeros, right? And we know that if there is no decimal here, that means the decimal is at the end. And in the scientific notation, we need the decimal at this point. So what we can say that if I write the decimal here, that means if I place the decimal at this place, so it is 4, 9 followed by 4 zeros. Now you can clearly see that here the decimal is shifted 1, 2, 3, 4, 5, 6 as a big number. So we should write this as 10 raised to the power 6. Once again, the decimal is being shifted here to the left, that is by 1, 2, 3, 4, 5, 6. So therefore, the scientific notation finally we should write as 7.49 into 10 raised to the power 6. That's the answer. Now coming to the next part, that is in the second part. This is based on the laws of exponent. So I'll first copy the question. This is x raised to the power a over x raised to the power b and whole power c, that multiplied by x raised to the power b over x raised to the power c and whole power a. Finally, it is x raised to the power c over x raised to the power a and whole power b. Now, we are going to apply two identities, two laws here. The first law is when same bases are divided, like when bases, like say, for example, if I write a over m and a over n, so the same bases are divided, then the powers are subtracted. So it should be a raised to the power m minus n. And the other one which we are going to use is if a raised to the power p whole raised to the power q is a raised to the power p into q, a raised to the power pq. Now, if I apply the laws of exponent in the first part, so you can see that we have same bases and the bases are divided. So we can say that the powers will be subtracted. So it should be a raised to the power x raised to the power a minus p, and the whole power will be as it is. Same we can apply over here. So again, this is x raised to the power b minus c and then whole power a. And finally, it is x raised to the power c minus a and whole power b. Now, power over power is power multiplied. That means this is x raised to the power a minus b multiplied by c multiplied x raised to the power b minus c. Here I'm applying this property here into a, and finally x raised to the power c minus a, that multiplied by b. Now, if I do apply distributive property here between these, that means we'll be simply opening the bracket. So we can say that a multiplied by c is ac minus b multiplied by c is minus bc. Same thing here. B multiplied by a is ba or ab, is all same. And minus c multiplied by a is minus ac. In the next part, we have c multiplied by b, that is bc, and a multiplied by b is minus ab. Now, once again, we are going to apply another property here, that when same bases are multiplied, the powers are added. That means this is a raised to the power m plus n. Check here. We have the same basis in all three parts. We have the same base, that is x. So therefore, these powers will be added. These powers will be added. Now, if I do so, it will be x raised to the power, adding the power, right? This is ac minus bc, adding this power to the previous, that is ab minus ac, and then adding this, that is plus bc minus ab. Now check here. You see that AC positive minus AC cancelled, minus BC plus BC get cancelled, and AB minus AB. So in turn, what do we got? We got this is equal to, I missed. So you can see that this is equal to x raised to the power 0. And what do we know? That any number raised to the power 0 is 1. So the final answer in that case is 1. And this is what we need to prove in the RHS. So we got this RHS as 1. RHS as 1. So we can write this is equal to RHS. And we started here with the LHS is equal to this.